we want to talk a little bit about the idea of continuity. I used the example of, let's say that Mike Tyson is in a bad mood. And he's drawn a line in the sand. It says, you cross that line, you're going to get hurt. Okay? Now, here's your position. If you're on this side of the line, there's no pain. You cross the line, believing Mike to be a man of his word, you feel pain, probably increasing pain, until you lose consciousness, which will probably happen fairly quickly. This is an example of a function that's discontinuous. On this side of the line, everything's okay. On this side of the line, you're hurting. Okay, we say there's no continuity here. There's something completely different on this side than there is on this side. The potential for pain does not increase continuously, it suddenly changes at a given point. Another example, of course, is a function that has an asymptote. Okay? The function is nice and continuous. There are no gaps, no jumps up to here, and it's nice and continuous past the asymptote. Only at this point is there a break in the function, and there's a break because the function is not defined at this asymptote. So there's another example where something would not be continuous. We have here a function, e to the sine theta over cosine theta, and we want to determine if this function is continuous between negative pi over 4 and pi over 4. Well, the cosine has values that change continuously between negative pi over 4 and pi over 4. Remember, the cosine is going to be the x-coordinate, so that's going to change from about here to here if this is a unit circle. So we're not going to have any serious problem. The cosine will change from the square root of 2 over 2 to 1 and back to the square root of 2 over 2 without any breaks or anything weird happening, nice and smoothly. The sine between negative pi over 4 and negative pi over 4 will also go from, well, it'll go from negative 0.71, because that's a y-coordinate, to positive 0.71, or negative square root of 2 over 2 to square root of 2 over 2 to be exact. And it'll do that continuously. The exponential function is nice and continuous. E to the x has a nice smooth graph that doesn't have any breaks. The sine doesn't have any breaks in it. So we conclude that everything here is going to be continuous. On the other hand, the function 1 over sine theta between negative pi over 2 and pi over 2 is not so continuous. Now the sine of theta changes nice and continuously from negative 1 to 1 as we go from negative pi over 2 to pi over 2. And that's all fine, but we have a denominator here, and we have to be careful that the denominator is never 0. Well, the sine certainly does pass through 0, because remember, the sine is the y-coordinate. So we have this point here where the sine is 0, the y-coordinate is 0, and we have a division by 0. And the function is therefore not continuous at theta equals 0. At the angle 0, sine theta 0, we have a discontinuity. Notice that that's not a problem up here, because this denominator, this cosine theta, is never 0. It never even gets close. Cosine being the x-coordinate, we never get over this far. Okay, so these are some examples of continuity and lack of continuity.